Hi, this is the second lecture of Chapter 1. In this video, we're going to cover Section 1.2, which is pictorial and tabular methods in descriptive statistics. So, the objectives for this section is the following. It is outlined on page 20 in the study guide. As we are splitting up Section 1.2 into two videos, in this video we are only going to cover the first four objectives, which is representing a dataset using visual techniques, constructing and interpreting the information in a stem and leaf display, construct a comparative stem and leaf display, and use a dot plot to summarize numerical data for a small dataset. So, let us remind ourselves of the two branches of statistics that we talked about in the previous lecture. So, the two main branches are descriptive statistics and inferential statistics. So, descriptive statistics can be divided into graphical measures and numerical summary measures. So, section 1.2 is all about graphical measures. This is what we will cover in this video. So, on page 9 of your textbook, they define some notation that will help us to have a better understanding of the data. So, we can denote the number of observations in a sample, and when you have two samples that you use simultaneously, you can denote that as M and N, or alternatively N1 and N2. And then, if you have a data set that has n observations on some variable x, you can denote the variables as x1, x2, x3 up until xn. So, these subscripts has nothing to do with the magnitude of the variable. So, x2 is not necessarily bigger than x1. So then, let us look at how we will construct a stem and leaf display. So, this is on page 10 of your textbook. So, let us say we have a numerical data set where x1 up until x consists of at least 2 digits. So, your first step will be to select one or more leading digits for the stem values. The trailing digits become the leaves. Then, you will list the possible stem values in one vertical column. For each observation, you will record the leaf beside the corresponding stem value. Then, you order the leaves from smallest to largest on each line. Then you indicate the units for the stems as well as the leaves. Let us look at an example. So, in 2020, 10 WST 111 students obtained the following marks. So, there's 10 marks that was obtained by students for WST 111. So, step 1 involves picking the leaves and the stems. So, if we pick the 10th digit to be the stems, that is indicated in red, and then the 1st digit as leaves, that is indicated with blue. Then, in the second step, we will list the possible stem values in a vertical column. It is important to not leave out numbers. So, there was a stem value of 2, and then the next one was a stem value of 4, but we have to include 3. This will aid in identifying gaps in the data. Then we record the leaf values beside the stems. Then we need to make sure that the leaf values are in numerical order. So we check every one that has more than one value. So for the stem value 4, 2 and 4 is in the correct order. 5, 8 and 1 is unfortunately not in the correct order, so we need to fix that. For 7, 6 and 9 is in the correct order, so we only swap around 1 and 8. Then the next step we have to, then you can read the values from here. So this value will be 51. This value will be 88, and so on. So the stem and leaf display conveys information about some aspects of the data. The first being, you can identify typical or representative value. You can extend of the spread for about a typical value. If there's any gaps in the data, if there's any symmetry in the distribution, the location and number of peaks, and the presence of any outlying values. The next type of plot that we're going to look at is dot plot. This is mostly for smaller data sets. So, such a plot gives us information about the location, spread, extremes, which is also known as outliers, and gaps. So, the values, the dots that's on top of each other, means that it's the same value occurring multiple times. So in this case, at 108, there's 4 dots on top of each other. This means that this data set consists of 4 values, 4 observations, that is equal to 108. This concludes this video for chapter 1. Please have a look at the next video, which is also part of section 1.2.